Hello and welcome back, my dear friends. And now we are going to study our final topic, which is LCR circuit. You might be pondering that why I decided to teach you LCR when we have already studied the L and C and R. Well, after 5 minutes, I am going to give you something that will blow your mind forever. Okay, so let's begin. So, what is LCR circuit? Well, if you place a capacitor, an inductor, and let's say a resistance together with a power source. Let's take AC this time. We have took so many times the DC. This is the symbol for the AC source of electricity that will provide the voltage. Okay, so this is capacitance, this is inductor, which we write from L, and this is resistance that is written with R. So that is known as combinedly LCR circuit. LCR circuit. Well, L and C are together and R is here. So this is LCR circuit. Now what we have, let's write the total voltage. So the voltage that we can get from the resistance is IR. The current is flowing. Remember the current I, that one. Yes, exactly. Plus the voltage that is going through this one. So Q is equal to CV. Remember. Okay, let me write that all. V is equal to IR. Q is equals to CV, the second one, and the third one is, can you guess? EMF is equals to di by dt. Yes, I missed the L, and here is our L. So you can place negative and positive sign. I am placing the negative sign here. Okay, now this EMF we are treating it as voltage. I'm going to tell you that what is the difference between EMF and voltage. There is a very slight difference. For this purpose, you can imagine them as the same. Now this is gonna be Q divided by C plus, actually the minus sign will going to appear, minus L di by dt. So this is the total voltage of LCR circuit. So this is our total voltage. Well, that's impressive. Okay, we have got that. But what else do you have for us? So we are pondering that there must be something that you are hiding behind the scenes and showing the simple stuff first. So just tell us that what's the adventurous part in this one. Okay, without taking so much time, let's proceed to that one. Okay, let's again make the LCR circuit. LCR. This time I will remember that I placed them in the order. Well, the order doesn't matter as everything in series itself, but still, if we care about the language that we are writing, I'm writing LCR, not CLR or something. So I am trying to make it in that such way. But for the calculation purpose, it will not going to make any difference. So that's pretty much okay. So this is L, this is C, and this is R. Okay, so there is something called as impedance. So what is impedance? Impedance indeed is the total resistance. Well, we already studied the resistance. So how this total resistance actually came? Well, what resistance we have studied is just for the resistance. But imagine the capacitance or the capacitor is also having some resistance, and inductor is also having some resistance in form of heat and all that such things. For that one, we need to write it down. So what it actually is? R square plus XL minus XC whole square. Well, I'm going to tell you in a bit that what does it mean, so don't worry about that. So let's just write everything first so that we can see everything. XL is omega L and XC is equal to 1 by omega C. Well, omega is frequency, and obviously L and C are the thing. What thing? Well, L is inductor constant and C is capacitance constant. So that's it. That's all, the whole idea of it. Okay, so this is impedance that he told us, but what does it actually make the difference? So we are not able to understand that. Okay, let me make one more thing. So this is XL minus XC. This is 90-degree triangle and this is resistance. So what can this be? What can be the line representing here? Okay, let me highlight that, which line I am asking. What this line is going to represent? Well, can you say that? Say it loud so that everyone will understand. Okay, so just by using the Pythagoras theorem, what we get here is the resultant. Well, that is the resultant, and that resultant is actually r square plus xl minus xc to the whole square. Well, exactly that we have written here. Congratulations, you have understood that. So this is the Z, which is impedance. But one last question is still here. Why we are writing XL minus XC whole square? Where this came from? Well, the logic here is very interesting. Listen very carefully. Okay, so Z is equals to, okay, let's remove this all the things and let's start fresh. Let me tell you one thing more. We are considering this y. We are going to come back to this y later. Okay, now let's proceed. So, what we have here, we learned impedance, which is total resistance. That is simply R square plus XL minus XC whole square. Well, that is wrong. You just wrote the same thing and you are saying that you're gonna learn something. See, this is the same thing that you have said. This particular we are talking about. You wrote the same thing. Okay, I understood. What inductor do? Well, just tell me what inductor do. It increases and decreases the voltage, means voltage variation. We can do voltage variation, right? Okay, what a capacitor do? Stores what? Charge in the form of energy in the form of voltage. So ultimately stores voltage. Now just imagine if I place, now listen to this part very carefully. If I place capacitor and inductor together, that's it, no power source, nothing, and somehow I charge the capacitor fully. So this is zero charged, or not fully charged at least. So what will going to happen after some time? What do you think? Well, that's the pondering question. Come on, answer me. Yes, this is going to get empty and inductor will going to get charged up. Then what is the work of inductor? Inductor will again throw all that charge to capacitor. So the game between inductor and capacitor will go on and on and on and on and on. So capacitor will going to charge the inductor, then again inductor will going to reverse charge the capacitor in this way, but it will charge the capacitor. So this is the first memory. Yes, the first memory design, that RAM and ROM design that you're talking about. So you stored a voltage. The voltage is not going anywhere. That exactly is the information that is getting converted into zeros and one, and that we decode and get our data. Well, you learned the first ever memory. Congratulations, my dear friend. And that I was talking about, that after 5 minutes something will going to happen. So what it has to do with this impedance thing, and why we have subtracted it? Well, we have subtracted this thing because it will surely going to lose some energy in practical purpose, because it is traveling through the wire or through some connection. So when anything travels through some connection, it will release some heat and some form of the things. So surely few amount of data get lost, but surely we encapsulate in that many layers so that our real data never get collapsed. And we sometimes also use the small battery. If you have opened your CPU and all that, you must have seen that thing too. So that is for maintaining the time of the CPU and to maintain and manage our memory system. So that is the best thing that we have learned, and now you know that how your pen drive is saving the things. There is the combination of the capacitor and inductors. Yes, it is complex when you are talking about millions and millions of small capacitor and inductor and other devices, of course, but this is the simplest form of the memory because we trap the voltage. So that is the thing. And when we want that data back, we just open a path from here or just anywhere and we get voltage out of it, and that voltage will going to get converted into the series of the zeros and ones and zeros, and that will going to give us the real data, that is you are perfect. Well, let's say I have saved this data, so this will going to get converted into boolean, and that boolean is actually getting stored in the form of the voltage, and that voltage is getting trapped in between these two, and that's how we store the data. So as this going into each other, we subtract one. Why we subtract one? Because the direction is reversing, first thing, and the second thing is capacitor is getting charged or inductor is getting the charge, so it is discharging each other in a way, charging and discharging each other, so we use the subtraction sign here. Resistance independent thing, so we have not messed up with the resistance. Okay, so that's about the thing. I hope you have learned that. Okay, now what is the phi thing that I meant here? Well, nothing special, that we can take it as 10 phi. So what is the value of the 10 phi? XL minus XC divided by R. That's all. That's all I mean with that. Nothing else. So it can be used in the calculation form sometimes, and we can just take the ratio of these two things. Okay, is there anything left? Well, obviously there is a thing that is left after even the memory part of it. So we have studied the impedance, we have studied the total voltage. Now it's time for studying the memory part and the EMF. So let's study the EMF first. What is the EMF? Indeed, EMF is electromotive force. Electromotive force. Well, it is force and we are using it in the form of the voltage. Voltage is energy. So how it is happening? Let's go inside the battery. You can imagine the dry cell. You are going inside, so you are safe, you are with me. Okay, so this is the battery. Imagine that the source of the electrons are releasing from this point, so there must be some internal resistance. Why must I said? Because ideally you cannot go with the zero resistance. You have to travel some path, there is some friction, there is some heat that is getting lost, and you are getting the energy a little less. So here what actually happened? The force, the heat is produced because of the chemical reaction. So the electron or the current is started moving. Well, surely the electron will move in this direction. I have not added the other things here so that you will not get confused. And this is the internal resistance. So the let's write the formula first so that we can get the clarity as per our real scenario type thing. EMF minus current times internal resistance. Internal resistance means with this, because this is inside the battery itself, that will going to equal to voltage. Means we are always going to get less amount of voltage. If the EMF of your battery is 20, you will never going to get 20. You might get 19.8 or 19.9 if it is very efficient, but never going to be 20. So this is the EMF dream and this is the reality. Okay, so what else we need to study here? We need to study that when it travels, it was a force. So the fundamental law of the physics tells us that work is equals to force times displacement. This is the simplest equation we have. So work can be treated as energy, work can be treated as energy or same as energy. So energy is equals to force, which is EMF in our case, multiply displacement, because it is traveling in the wire. So that's how it becomes the energy, and that's why we are getting the voltage here. which is energy. We are getting the voltage in the form of an energy, so we can subtract only the energy thing here. So it is E. And why? Where this I come from? Well, the electron traveling current is going, you remember all that story. So the current is flowing or coming here, like electron is going from some other route, so and somehow it is connected all the way across the thing. This is known as the closed circuit that we study in our junior classes, like there is a light bulb and there is a battery and then connected, this is the closed switch, and in the closed one this will start glowing, and that's the whole story of it. So it is a cyclic process. So that's all the matter of the fact. In this was the current. Now you understood that why electromotive force is called as force, and why we took in the case of inductor the EMF part, because it was the force part and we differentiated in the form. But you can imagine, if you take the value of D as equal to 1 for simplicity purpose, so you will also going to get that EMF is equals to voltage in case of IR is 0. Actually small r I should write. IR is equal to 0. I mean with this one. If this becomes 0, so EMF become equal to R. So current cannot be 0, but resistance, well, we can hope that someday there is no resistance, but for now we cannot eliminate the resistance completely. We can reduce it but cannot eliminate it. That's why I made the efficient part here, that 19.9 till is possible, but maybe 20 is not possible, at least till now. So this is all about the EMF thing. And what else we are left with? Well, we have studied the LCR circuit, and we have studied that what is impedance, and we have studied how the memory actually works, and you learned how to make a simple memory, and then we have studied the EMF. So what is left? Well, I would like to teach one more topic here. This is the last topic, that is known as resonance. So what we call as resonance? Well, resonance in the phenomena in which the frequency of two things gets equal. Well, very simple. Like when you call someone, you dial some numbers, and that will going to ultimately throw the midway. We are not going to the deeper story part of it, but through the signals somehow between the antennas and all that, whatever is coming in between the transmitter and receiver thing. So ultimately it is resonating. Your signal is resonating with the other device. So this is device 1, this is device 2. They both are in the resonance, so they can communicate with each other very much easily. Well, I used to think that why should not I make a separate course for making a walkie-talkie, but I tried it once. I made my walkie-talkie and it did not work. Later I found that I forgot to put the batteries inside. Okay, never do that thing. Okay, let's see that what happens in the LCR case, the resonance. So R has to do nothing with this because R is independent. We can just vary the L and C. R is a physical thing, so these two are also physical equipments, but we cannot change the value of R. But we can change the value of C and L on the basis of the charge, that charge and discharge and voltage and all that such things. So we can change that. Okay, so let's remove this and we have LC. Now what with the LC? Remember, XL is equals to XC in the case of resonance. This is our condition. So what is the frequency? What must be the frequency for that? Well, let's see. Omega L is equals to 1 by omega C as their formula prescribe us. Now when we solve it, we get omega square is equal to 1 by LC, and finally the value of omega is equals to 1 by LC, but in root over LC. So this is the frequency that we require. So this actually happens when you dial your phone, dial someone's phone number. When you dial someone's phone number, your inductor and capacitor are actually working inside some way. I'm giving you the simplest possible idea so that you can understand this. So somehow it is connected to the other resonance, and that's the way of connecting to the other device. So this is about the resonance of L and C, and I told you about the frequency of these things. And that's the wrapping point for this section. I hope you have enjoyed the electrical technology. I gave you the entire glimpse of the electrical technology that you are going to see frequently here and there everywhere. So you must understand everything because you are my student, you're studying with me. So you must have to learn everything. And whatever you don't even learn, you will going to ponder upon that and you will learn it someday. So with all that good things, we are going to wrap up this section, and this is the ending point for this section. In the next section we are going to learn the advanced topics like digital logic design, computer organization, architecture, and etc. So take care, god bless, and see ya.